Now we are going to derive the variance of the least square estimator. That is variance of beta 2 cap equal to sigma square by sigma. And here we want to prove that variance of beta 2 cap equal to sigma square by sigma. Let us see how we can derive this. The variance of beta 2 cap equal to the expected value of beta 2 cap minus the expected value of beta 2 cap the whole square. This is the variance. That is, here the expected value of beta 2 cap, we already derived that it's equal to beta 2. It is equal to beta 2. That is, expected value of beta 2 cap minus beta 2 square. This is the variance. We will discuss about the derivation of this variance. And we know that beta 2 cap equal to sigma of xi yi by sigma xi square. This equal to sigma of ki yi, and yi equal to beta 1 plus beta 2 xi plus ui, and beta 2 equal to, then we can replace this yi by this linear equation, then multiply the bracket by ki, then we'll get beta 1 plus sigma ki plus beta 2 into sigma ki xi plus sigma ki ui, then apply the properties of ki xi, then this ki equal to 0, then the whole term will be equal to 0, ki xi equal to 1, therefore the remaining term is beta 2 plus sigma ki ui. From this we can derive an equation, that is beta 2 cap equal to beta 2 plus sigma ki ui, then beta 2 cap minus beta 2 equal to sigma ki ui. That is, here we derived beta 2 cap equal to beta 2 plus sigma ki ui. Then take this beta 2 to the left hand side, then we will get beta 2 cap minus beta 2 equal to sigma ki. Then replace this beta 2 cap minus beta 2 by this equation. Then we can rewrite this equation as expected value of sigma ki ui the whole square. Square is here. We replaced this beta 2 cap minus beta 2 by this equation, then equal to expected value of sigma ki ui the whole square. Then we can elaborate this equation like this, that is expected value of k1 square u1 square plus k2 square u2 square plus kn square un square plus 2k1 u. Then apply the properties, that is expected value of ui uj equal to 0 and expected value ui square equal to sigma square. Finally we will get the equation as some of the terms will be removed, or it will be equal to 0, that equal to expected value of sigma ki ui the whole square. Here k1 u1 k2 u2, then we can rewrite this equal to expected value of ki ui the whole square. This equation can be written as sigma ki into expected value of ui, sigma ki square into the expected value of ui square. That is, now we can apply the expected value here, or now we can take the expected value, which will give the sigma ki into expected value of ui square. Now the expected value will get sigma ki into expected value of ui square. The expected value of ui square equal to sigma square. Then the remaining, then we can say the variance of beta 2 cap equal to sigma square into sigma ki square. That is, sigma square, variance of beta 2 cap equal to sigma square into sigma ki square. Then ki square we already defined equal to 1 by sigma xi square, that equal to sigma square by this divided by sigma xi square. Here this step is important, that now we distributed this expected value, then we will get sigma ki square into expected value of ui square. This expected value of ui square equal to sigma square. Then variance of beta 2 cap equal to sigma square into sigma ki square. That is given here, variance of beta 2 cap equal to sigma square into sigma ki square equal to 1 by sigma xi square. Then this equation can be written as sigma square by 1 by sigma xi square can be equal to sigma xi square. This is the variance. Therefore, the steps involved is this. Variance, first defined variance of beta 2 cap. Variance of beta 2 cap equal to expected value of beta 2 cap minus expected value of beta 2 the whole square. Then since expected value of beta 2 cap equal to beta 2, this equation can be written as expected value of beta 2 cap minus beta 2 the whole square. Then replace this equation using this one. This derivation is important. Use the this equation beta 2 cap equal to sigma xi by pi, then equal to sigma ki y, then distribute, then replace ya by the linear equation beta 1 plus beta 2 xi plus ui, then multiply the whole term by ki, then apply the properties of ki, then we will get beta 2 cap plus beta 2 cap equal to beta 2 plus sigma ki ui, then take this beta 2 the left hand side, then beta 2 cap minus beta 2 cap equal to sigma ki, then apply this formula here. We will get expected value ki square, then expand, apply these properties ui uj, these terms will be removed, remaining portion is ki ui square. Then distribute the expected value, that is we will get sigma ki square, the first term, into the expected value of ui square. Then here expected value of ui square equal to sigma square. Then this equation can be written as sigma square into sigma ki square, that is variance of beta 2 cap equal to sigma square into sigma ki the whole square. This is given here. Variance of beta 2 cap equal to sigma square into sigma ki square. Then replace this ki square by this formula, then we will get sigma square by sigma xi square. This is the variance of beta 2 cap. Then standard error equal to root of this one, where standard error is root of variance, that is root of variance equal to the standard error. Then take the root of this sigma square by sigma xi square, that equal to sigma by root of sigma xi square. So root of sigma square is sigma. Likewise, we can find out the variance and standard error of the beta 1 also.